My name is Nathan Kane, and I'm a front-end engineer at a company called Pedal. We're making a new credit card with no fees using machine learning for our risk models and with React. So I wanted to share a bit of a story and some lessons learned from how we approached our mobile app development, squeezing as much use out of our React web components. So just in general, coding's really fun, and it gives you kind of the warm and fuzzies. And for me, a lot of that comes from doing more with less. Less code, less effort, less thought. And whenever there's a project where I find myself doing more to get a little bit less, or having to think a lot or do a lot of work, that just kind of bothers me. So I always look for the lazy route. And I want to share a little bit of how we're doing that at Pedal. So really it's about not repeating yourself. Don't repeat yourself, dry. When you want to build an app for web, Android, and iOS. So if you want to go kind of the traditional route, hiring up a big team, going out and finding that iOS engineer, Android engineer, and then teaching them your product, maybe having them rewrite a lot of the same business logic you already did and build the same components the same way. There's bound to be some discrepancy, some mistake, or just some difference across the platforms. And then so you want to build a new feature in the same way with kind of the parity across platforms. Again, the same problem. You have to have a meeting with them. The designer has to work with 3 different teams. And then the user at the end of the day is going to have a kind of a worse experience, most likely because there might be some subtle bugs on one platform. One component might not behave the same way. And so we wanted to solve this problem, especially being a small startup with like about 3 or 4 engineers. How can we be scrappy and get our at least initial product out with the least amount of work and code? So just at a high level, setting things up, I think about it as we're really building a core JavaScript app, a collection of features that's almost like a package or library you'd download on NPM. And then we're building it for each target. So native mobile, obviously React Native gets us to covering both of Android and iOS really well. And then on the web, building with, say, Webpack or another module bundler. And so really the theme of this talk is, or the kind of the one takeaway is, to accomplish this, we found the best way is to write in the way React Native understands, but then on the web, compile it for the web. So if you write it for React Native compiles that just fine, but then you have to do a little bit of tweaking and configuration to get it to work on the web. But a lot less work to get to 3 platforms. So just thinking conceptually about how apps are structured. This is how I mentally think about it, kind of a component tree, Russian nesting dolls of components. On the top, we have our app, usually, which has a few different responsibilities. Often it's to just kind of set up the initial rendering, maybe connect the router, provide a lot of the global state that your React app will need. Right beneath that are these large features, often routes of your app as you're navigating around. And they're also just kind of how you arrange the components within it. So a login will have form, some text, some inputs, a submit button maybe. And the login is kind of the definition of how those components are arranged around each other and composed. And often it's injecting some state from, if you're doing something like Redux or MobX, it often happens at that level. And then we're probably pretty familiar with reusable small components. So there's a lot of libraries like a Bootstrap or a Material Foundation where you can pluck out a button or an input field, and it just doesn't really care about where in the component tree it is. It just does its job, and you pass some props to it. And think about these for how we want to reuse and approach this cross-platform project. So the top level, it's really only one or a handful of smallish components. They have a big job. They have to set up the whole app and kind of arrange the features within them. But the top level component, it's really only a few, so you don't get a ton of payoff for making that reusable. And often it's connecting into, say, like browser history or something for the router. So you're kind of working around dependencies on the platform, like the web, the browser. So I found to just kind of, it's better, easier at least to start to do this there's an app for the web and an app for the React Native app, and they're separate for now. It's really at the middle meat of the app where you get the highest kind of bang for your buck, because you're getting a full feature, and it's easy enough to debug what is breaking in React Native. And I'll talk about how you discover that. At the bottom, these are kind of the atomic, almost the primitives that you build your app up from. But whenever they're within a feature you want to use, you have to convert all of them to being cross-platform, because as we'll see, React Native is really picky and kind of finicky. So the workflow we've gotten ourselves into developing this is to try to pluck a feature out of the web, throw it in React Native, and see what breaks, basically. It's like a troubleshooting exercise, and you kind of then drill down into the small components that are causing the bug, and then rinse and repeat. So it's kind of a naive example, but say your login screen is something that you've decided is a feature you want to work equivalently across all platforms. Here we've packaged that up into this kind of central library of components, and then pull it out and dropped it into this wrapper. And this can be living in React Native or in web. It doesn't, at least as written, doesn't matter. But then you'll hit the red screen of death, almost certainly. And the error messages are about as helpful as that little guy. Often in React Native you'll find, at least for me. And a lot of the common things kind of obviously are you're trying to do something on the web that doesn't exist in React Native, and React Native just completely crashes. And so it's rendering these web-specific components, div spans, or accessing like local storage or cookies, and there's no concept of those in React Native often. Or you're doing something in CSS that React Native doesn't allow. It's very, very strict. If you want to do a hover state or a cursor, it's just going to say, nope, nothing at all may render because you're trying to hover, which obviously isn't a thing in mobile apps. The last one was just kind of the random idiosyncrasies of the React Native project. There's just kind of a lot of rebuilding that has to happen, and the dev server might crash for a reason you don't understand. And so there's some helpful tools like Expo that abstract a bit of that away and give you a pretty handy dev server that recompiles and hot reloads and gives a little bit more friendly debugs in Chrome Dev Tools, which is cool. Okay, so down at the bottom layer of that pyramid, the primitives, so there's an awesome library that enables a lot of this and lets you write the bare minimum code with the least effort in terms of supporting all platforms. So it's called React Native Web by Nicholas Gallagher at Twitter, and it's these components that they are built to mimic the React Native API, which is these views, text input, touchable highlights like a button. But on the web, they'll render out to divs, spans, inputs, buttons. And so you can write them that way and not have to worry that they're going to work on the web. Another great talk that goes really deep into this is from Leland Richardson on React primitives. So can we use React as a platform to write things this way, and then they'll work in like VR and whatever else will come next. And so when you need a bit more customization, you want to do something on the web you don't want to do on mobile platforms, like maybe some accessibility attributes, or you just want to use the kind of HTML form handling. One way to do it is to break apart your component into this like 5-headed monster. So say we want just a link, right? An A tag, an anchor tag. This is the way that gives you like the fine-grained control over how it behaves on that platform. So in this example, we have obviously for each platform, they have an extension for that platform, .android, .ios, .web.js. In the web, it's just the A tag with an href. Much more semantic. Obviously, screen readers and search engines can find that a lot better than if you did just a div, which we do in the mobile.js, which is what we'd want to use on iOS and Android, and that's just like a text block with an on-press handler that does the routing. So this gives you a lot of control. It's a bit more work, obviously. You didn't just write one anchor tag, but to every other component that imports this anchor tag, it doesn't have to know about the implementation details of each of those files. It just says, I want an anchor tag, reference that directory, and the bundler will be smart enough to know that, hey, I'm on web, I'm Webpack, I want the web version, or I'm React Native, I want the iOS version if I'm on iOS. I'll talk a little bit about how to set that up. So this is the notorious Webpack config, and the one property we use in Webpack for this is aliasing. So like I said, we're writing for React Native, we're compiling for the web on the web, and this is exactly how you say you want to use React Native and you're importing things out of that, but under the hood, you're telling Webpack, whenever I do that, whenever I say I want a text component from React Native, actually grab it from React Native Web, and same for React Router and any other libraries that have like a native version and a web version. And then you tell it to grab the .web.js when it can. And then React, because we're writing for React Native, it just kind of works. The compiler knows, just grabs it out of React Native, and when it's running an iOS bundle, it'll grab it from the iOS.js version. And then even more granularity, but even more kind of ugliness and effort in your code is just sniffing for what platform you're on and wrapping any platform-specific behavior in that block with platform.os. And the beautiful thing is all of the rest of your app, the non-view layer, just kind of works. So at least it did for us. All the Redux, all of the fetching HTTP methods, any kind of libraries that are just utilities will just work because it's JavaScript. And for us, that was honestly a majority of our app. So it's a huge win. And a lot of the business logic you don't want to write again. Like we're kind of a banking app, so there's a lot of like interest rate calculations. You just don't want to write that multiple times if you don't have to. So it just kind of came along for the ride. It's really the view layer you have to focus on. So yeah, so far we've been getting really high reuse, I guess. Like 90% of our source code just kind of lives in this one central JavaScript app, and we just pluck out what we need for each platform. That probably will actually decrease over time, in that we want to do specific things for mobile we won't want to do on the web, but for the core app, it's almost writing it once, writing 90% of it, and then having it just run across platform. And I put up a starter app for this on GitHub that it's in like a mono repo that has a web, a native, and the feature library, we're calling it. And just the configuration to get that all to work. So thanks so much. That's all.
What are the performance issues?
Yeah, I think your mileage may vary on specific on apps that require like really heavy performance, like games or really rich content. For us, that hasn't been an issue, and I think it's getting a lot better. The only thing is like the list view can be a little bit laggy. I would say like don't choose, and this is just kind of a React Native issue in general, but React Native just wouldn't be my first choice if I was building a game or like a VR thing, you know. But so far, no additional issues on top of what React Native normally has.
So between your web experience and your mobile experience, are they pretty much the same? Or if there's like this different interaction that's happening on the web, how do you handle that?
Right. For us, it's pretty much feature parity for our current set of requirements. But use one of the techniques in terms of using that .web.js platform extension to say, if this button needs to do something totally web specific, it can be contained in that only, and it won't affect React Native. But yeah, you just need to build kind of a feature and call it the web version of that, and it's kind of it's not the best, doesn't give you the most reuse, but if that's what you have to do, it's often a conversation with your designer to say like, hey man, we could do this in a day if you just make this small change to make them kind of congruent and consistent across platforms. But if that's something that's like your designer really needs this to be different on this platform, you might have to put in the extra time and use that kind of decomposition technique.
Okay, thanks so much.
Thanks.